Okay, here we are on day 10 notes, 2.4 graphs of functions and relations. So we're going to talk about what a relation is, what a function is, and then we're going to graph different types of equations, and we'll determine if they are simply a relation or if they were also a function. So before we can begin, we need to understand what a relation is and what a function is. So let's go ahead and look at the definition. So a relation is a set of ordered pairs. So if you take a look over here we have a set of 3 ordered pairs, okay, x and y's. All right, a function is a relation, so it's a specific type of relation for which there is exactly one value of the dependent variable, or y value, for each value of the independent variable. For each x value, there is only one y value, okay? I kind of like to think about it as birthdays, all right? Where let's let x be a person, and y represents the birthday. So each person is only allowed to have one birthday, okay? So each x is only allowed to have one y value in return. All right, so that's kind of one way I think about it. Okay, so how do we determine if, when looking at a graph, it's a function or simply just a relation? Well, there is something called the vertical line test. So imagine holding your pencil vertically. I'm going to try my best with this laser. Okay, so hold your pencil in this vertical line. All right, and if that vertical line represents the one x value, okay, the one person, okay? So what we need to do is we're going to take this vertical line, all right, and at any given point, if that vertical line only crosses one point on the graph at a time, then we can go ahead and say it is a function because it passes the vertical line test. Okay, so for instance, this first example is in fact a function because each x value only has one y value. Okay, it passes the vertical line test. So we can say passes vertical line test, VLT. Okay, now if we take a look at this next example over here, okay, what do we notice about this right here? If I draw in a vertical line, I am passing that in multiple places. So this represents, that red line represents one single x value, okay, but it has two y values in return. That one person has 2 birthdays, and we cannot have this. So this is not a function. This is simply just a relation. Okay? So it does not pass the vertical line test. All right? So it's a relation. It is not a function. Okay? Okay, now what we're going to do is we're going to actually plot the equation. We're going to graph, and then from that graph, we're going to determine whether or not the relation is a function. Okay, so all of these represent relations because it's comparing x and y values. We'll have ordered pairs. All right, so we look at this first example. The absolute value of y equals x plus 1. Okay, we might have seen some absolute value equations before and graphed those, right? So we should be thinking there's some sort of V. It should look like a V, but this time it's y that has that absolute value. So how do we create a table to get this graph? Well, I say since something funky is happening to y, I'm going to choose some y values, and then I'll solve for x, okay? So because it's absolute value, I'm going to choose some negative values for y and 0, and then some positive values for y, and hopefully I get a good shape to the graph. So maybe we start at y being -2, -1, 0, 1, and 2. And then when we plug this in, we should be able to solve for x. Okay, so when y is -2, we're going to get x to be 1. When y is -1, we're going to get x to be 0. When y is 0, we get x to be -1. When y is 1, we get x to be 0. And when y is 2, we get x to be +1. Okay, so now this is enough points, I think. We should start seeing that, hey, at this point, we've got symmetry on both sides, right? The x values start becoming the same. So I think that's enough to go ahead and plot our graph. So we will. So I will plot the point 1, -2. We've got the point 0, -1. We've got the point -1, 0. And back to 0, 1. And 1, 2. So we will have a graph that's going to look something like this. Okay, now based on what we just talked about and the example above, I think we should be able to determine that this is not a relation or not a function because it's not passing that vertical line test. There's multiple places, infinitely many places, where if I were to use a vertical line, I would get 2 y values in return for my 1 x value. So this is simply just a relation. All right, so let's take a look at the example below, okay? So if you were to graph y squared equals 3x, you have to think to yourself, all right, well, what variable has something funky happening to it? Which variable is it going to be easier to solve for by plugging in for a certain variable? Okay, so this is similar to above. We've got y squared equals 3x. Something funky is happening to y. It's being squared. So you should recognize that it's a quadratic, but it's with y being squared. So what's that going to do to the graph? So again, I want to choose y values, and since I have a y squared, I want to make sure I choose some negatives, 0, and some positives. So I might choose the same values that we chose in the example above. So we could go ahead and say y is -2, -1, 0, 1, and 2. And now when we solve for x, hopefully it's relatively easy, and then we'll go from there. So when y is -2, we're going to get 4/3 for x. We might want to choose some other values, and we'll go from there, but let's start here. If y is -1, -1 squared, and then we have to divide by 3, we're going to get 1/3. When y is 0, x will also be 0. When y is 1, x will be 1/3 again. And when y is 2, x will be 4/3 again. All right, so we're starting to see symmetry, hopefully. So we can call 0, 0 our vertex. And if we go ahead and plot this, now one thing I notice is my x values are fractions, relatively small. So what we can do is we can go ahead and rescale our graph. And I'm just going to call each of these tick marks for x as 1/3. All right, so long as you label it, it's no big deal. So we can say, all right, that's going to be 1/3. All right, that means we'll say that this is, and y could be 1. That's no big deal. Okay, so I'm labeling my grid. So if each tick mark for x goes up by 1/3 and each tick mark goes up by 1s for y's, that's no big deal. You can have different skills so long as you label everything nicely. Now it'll be easier to plot these. Okay, so we have the point 4/3 -2. So 1, 2, 3, 4, -2. We have the point 1/3 -1. We have the point 0, 0. We have the point 1/3 +1. And we have the point 4/3 +2. So now we go ahead and we have ourselves a sideways parabola. All right, ask yourself, is this a function? Does it pass the vertical line test? For each x, is there only one y? Or is it simply just a relation between x and y? Hopefully you recognize it fails that vertical line test. So therefore, we have ourselves simply a relation again. All right, our last example here. Y equals the square root of 1 minus x. Which variable has something funky happening to it? Hopefully you recognize that x has something funky that's happening to it. So we're going to choose values of x first, and then we'll solve for y from there. Now another thing we have to think about with square roots. What values can't we take the square root of? Well, hopefully you say we can't take the square root of negative. So I do a little side note and I say, okay, well 1 minus x, it can't be negative. So it has to be greater than or equal to 0 in order for me to take the square root of it, okay? So now if I go ahead and I solve this inequality, I essentially have 1 is greater than or equal to x, or we can flip that around and say x has to be less than or equal to 1. Okay, so that's going to help me start figuring out which values for x I want to plug into my table. So I want to plug in starting with 1, okay, and according to this inequality, I want to choose values that are less than 1 as well, okay? So since x can equal 1, that's okay. And now I choose values that are less than it. So we could go ahead and say, all right, 1, let's see, 0, then we go -1, and just for kicks, let's do one more, -2. All right, so now when we go ahead and we plug in, when x is 1, we get the square root of 0, which is 0 for y. When x is 0, we get the square root of 1, which is simply 1. When x is -1, we get the square root of 2, which doesn't simplify, so we can leave it as the square root of 2. When x is -2, we get the square root of 3. Again, doesn't simplify. So let's just do one more, just so we have another nice number. When x is -3, we get the square root of 4. Square root of 4 is 2. So now we'll just focus on plotting these 3 points. Okay, but again, we have to be aware that when we're plotting, this is our domain. X has to be less than or equal to 1, so we're going to have a starting point there. We'll get into graphing square roots a little bit more later on with more detail, but this is a good start. All right, so we have the point 1, 0. We have the point 0, 1. We have the point -3, 2. I could go ahead and plot those other 2 points, but those are just estimates. So these are for sure nice points that we have. And our graph is going to look like that. It's going to keep getting bigger. Okay, it's going to keep, the y values will keep increasing as x is going further and further towards -infinity. Okay, so now you have to ask yourself, is this a function? Does it pass the vertical line test? Or is it simply a relation? So if you take your imaginary vertical line or you use your pencil and hold it vertically, no matter where I am, each x value has only one y value in return. So this is in fact a function. It passes the vertical line test. And on that note, we are done. So if you have any questions with this video, make sure you bring it to class the next time we see you. Have a good day. Bye.